So, we will continue from where we left last time. So, we see what did we do? We understood that the conventional printing, okay, the conventional printing is a complex process because it requires a lot of things, and so there can be another alternative which is called the transfer printing, which means you print somewhere else and then transfer the print. Out of these there were many options that we thought, but sublimation transfer printing, which sometimes also known as a dry transfer, is more commercially successful, particularly with the dispersed dyes, that also printing on polyester, because polyester cannot be printed with any other dye other than dispersed. Although dry transfer printing can be done on acrylic, on nylon, or any other such material which can take dispersed dyes. But nylon can be printed by acid dyes, metal complex dyes also. Similarly, acrylic can also be printed by cationic dyes, and therefore, it appeared as if the polyester and disperse and the transfer printing, sublimation transfer printing were made for each other, well suited kind of question. So, other methods also available, as we learned, there are wet transfer, melt transfer, film release transfer techniques are also available for doing this transfer printing. And so, we will learn about them, but as I told you, the sublimation or a dry transfer printing is the most popular and commercially successful process. So, we will spend some time on printing of paper. Why should the printing of paper be any different than printing of textiles? One of the interesting thing which we can appreciate is that the textile is something which is much more stable. It does not get affected by wet conditions, alkaline, high temperature. So, generally very flexible and more durable in that sense. Compare this with paper, and paper, if we refer to a paper made from cellulosic material, you can appreciate that this material is not going to be as stable to moisture, tear resistance, etc., are not going to be very high. But from the point of view of printing the paper, there may be advantage. One of the advantage obviously you can expect is that there is going to be a very smooth surface. So, if you want to print any details, then on a smooth surface it is easy to design, develop prints which have fine lines, finer prints, which is more difficult as far as textile is concerned, because textile surface is a very rough, undulating surface, and so from that point of view there will be some advantage. So, one important thing is essentially whatever is being used for transfer printing as a paper is cellulosic product. So, and because of this we are also lucky that the cellulose does not have any real affinity for a dispersed dye. So, if you print a paper with a dispersed dye, and then as we understand there is sublimation involved, so you are going to be increasing the temperature of the paper and fabric combination. So, the dye is going to be vaporized. The dye can go anywhere, but because cellulosic material does not like the dye, affinity is low. So, the most of the dye is going to be transferred to the polyester, which is a fabric, and therefore, efficiency will be also high. If suppose instead of that we take, let us say, a polyester film or make a paper of polyester, which possibly, and then print that and then try to work it out, you will find most of the dye will also be going to the polyester part or any other material that you can think of. And so, this is an advantage which is interesting advantage. So, dispersed dyes get the sublime and then get fixed onto the polyester, which is what we actually wanted. Obviously, because the contact is going to be very close and therefore, the boundaries of the print are going to be almost replicated on the fabric as it is. So, it appears it is a very simple process as long as you are able to get a printed paper. So, if the printed paper is good, then the transfer will be easy. So, generally this is the principle which people thought should be able to attract the commercial interest, and which happened also. So, the interesting part is in this process there is a polyester, then there is a paper which is a printed paper, and then you have machines which will be able to compress, pressurize and then heat it up, right. So, it appears this raw material which you are actually going to be using is costly. And so, when you talk about the cost of printing, paper cost, printed paper cost is one of the major costs. And so, people should be concerned as to the right kind of paper, right kind of printing to be done, so that you do not have waste. Once you finish printing paper correctly, then life will be easy. So, people will ask what could be the GSM? GSM means grams per square meter of the paper. Higher is the GSM, higher is the cost. So, one would have tendency to use as low GSM as possible, which is suitable for a printing technology. So, it is the technology which will say, well, this requires higher GSM, this requires probably medium GSM, and you can work around. And so, because the cost of the paper is important, so people like to use, but printing technology, paper printing technology is the one which also have to be seen whether they can take up. For example, you can have a machine which is printing in a continuous manner, or you can have sheet printing. So, where you print one sheet and the sheet is removed and the next sheet comes. And so, if this kind of a thing is there, so the paper has to be shuffled, moved from one place to another, and therefore, his GSM cannot be very less. But if it is a continuous sheet, maybe you can afford to have a low GSM as long as the tensions are adjusted correctly, because unlike the textile fabric which can skew, like knitted fabrics can skew more than the woven fabrics. If you do any skewing in paper, it will generally get torn. So, it is important that alignments are done correctly, and so the only thing which goes in the favor of the paper is that it is a stable structure, generally no skewing. So, printing can be good, but care has to be taken. So, GSM probably will be decided. Some other considerations which one may like to keep in mind: the penetration of a dye. Now, how much dye should be there on the paper? So, invariably one may say, well, I do not want any penetration, let the dye be on the surface. Yes, that is good, but because of various capillaries that may be available, and while you are printing, there may be, it is called ink, for example, is liquidish, it will have its own. So, whenever you put anything on the paper, something will go inside as well. But if it penetrates too much, then the dye has to traverse all that path back in the vapor form and come out and then go to the fabric. So, you would like to have as less penetration as possible, but if there is no penetration, it may be because they may be available as rolls. When you open, close, wind, unwind, you might find there is a scratch and the print is gone also. So, you would not want that as well. So, there is going to be some amount of penetration which you will like. Excessive you do not want, but you can't say that there is no penetration. Sometimes to make the surface still smoother, people may say, well, we can apply some coating. So, it is a glazed surface, very nice, but sometimes people say to have still more clearer prints, you may like to give a coating. For example, if you have photographic paper, which people use for making the photographs, it is a coated paper, and so it is expected that the ink when it drops will obviously not spread and stay wherever it is. So, those kind of considerations can also be done. So, paper may not be just a simple paper, may be actually a treated paper, and therefore, the cost can also increase. So, what is, of course, GSM is one, but strength of paper, if it is from the cellulosic material, they always call as a fiber length, So, you make it from bamboo, you make it from any other tree or whatever. So, fine nice papers, as they say, the fiber length there is larger. So, strength also comes from that. Generally, we believe that cellulose is not going to be degrading very easily, not at the temperatures that we are looking at, but still yellowing can take place. So, one should say, well, it does not have any impurities as such. So, you let us say you stay a newspaper, which printed newspaper, if you look at the color of the paper, it is not white, but it is good enough because the purpose is that you read and throw. But in this case, suppose it is not a white paper, that means there is some pigment there which is giving color. Based on whatever happens, it can get some impression otherwise, or some oxidation kind of thing can also take place and then yellowing. So, it will be interesting that the strength is high, it does not degrade very easily. Obviously, we expect that during the manufacture, let us say you have done a bleaching, it should not happen that the bleaching chemicals or the one after wash or whatever in the pulp formation are still continuing, because in that case, based on whether acid is continuing or alkali is continuing. So, it is a basically neutralized paper, and expected that it is not going to be interacting with the dye and will not affect in any way the characteristic of the dye, which in our case the most important character is sublimes. So, you do not want any interaction. Then the face and the back of the paper, like your face and the back of the textile fabric. So, face is always good, the back you do not care so much. Similarly, here also the face will be the one where you are going to be printing, has to be more smooth, more uniform in every sense, and back you can probably still may have little rough, because the smoother is the surface, the better is the details of the print. Then there is this ghost images, means that during printing, if there is a slippage for whatever reason, then a secondary image can be produced. Or when you reverse it, when during transfer also, if there is a slippage between the fabric and the paper during the transfer, or when you are removing the paper, paper has to be removed from the fabric surface at some stage. So, if there is any slippage, you might find another image which may be lighter, but it still appears like a ghost image, a secondary image being produced. So, these things have to be seen during printing of the paper as well as during transfer. So, both times, if anything like this happens, then obviously it is a bad quality print. Whatever you have done good before has no meaning. So, continuing with the paper only. So, expected thing is that it will have a good release of a dye vapor from the ink layer. So, there is a layer of ink. So, there is paper and there is ink. Now, you can start accepting that textile people call it a printing paste, the paper industry calls it ink. Not only that, the viscosity of this ink when it is being printed is much lower compared to what we use in textiles, because technology is generally different, which is acceptable technology, which is commercial technology is different. It is expected that should have low substantivity. Fortunately, cellulose and dispersed dye do have, but from the point of view of a principle, it could be any paper, any sublimable dye, any textile could be the one which accepts there. So, it is expected that you will be heating up to 220 because you want it to sublime. Polyester transfer and stability is good around this temperature. So, its melting temperature may be 250 to 255, but the transfer that takes place at this temperature. So, we expect that during this period, which may be very small, the temperatures can be high, and these temperatures will also depend on what type of a dye that we have used, because every dye does not have the same sublimation temperature, but you still have to optimize. It is expected there will be no tear or degradation during the transfer as far as the paper is concerned. So, permeability. So, if you have a low GSM, that means at the molecular level, because now you are talking about molecule of a dye which is in a vapor form and not a particle. So, if you look at any paper under a high magnification microscope, you say, well, it said it is a very smooth surface, but it is not as smooth. So, from a point of view of a molecule, so there are pores everywhere, and so how do you remove or reduce the permeability is either by coating or by high compression and glazing. That is, one side is highly glazed, and so you should have low permeability. So, the dye goes only in one direction. In a vapor form, obviously one is substantivity towards the fabric, other is the permeability is low enough that the dye is not low enough that it goes through the paper on the other side. Good dimension stability is what we expect and generally is there. That is why the GSM comes into play. Higher is the GSM, stability, dimensional stability is better, but higher is the GSM, the cost also is an issue. So, one can probably be thinking of 50 to 80 GSM type of a paper which may be used for printing. So, it is calendared. So, calendering we understand. So, calendering means at least one roller is a very smooth roller. So, that becomes the face of the paper which finally is going to be printing and will give you a glazed surface. So, how can we print? Yeah, I have written rotary because this could be a commercial kind of a, but any screen printing which you have used for textile can also be used for paper printing. All right. So, in that sense, if in lab you want to do any kind of a paper printing, you can do it, all right, as long as you have a good recipe. So, you can actually think of going to the lab and actually making a paste of a right dispersed dye, make some kind of thing and test it out whether any transfer takes place or not and how much is the transfer taking place. So, this process is well known to the textile industry. So, if tomorrow the industry itself wants that we will have put up our own paper printing system, this machine probably can be used, except that if it is a rotary screen, so how the paper roll is going to be opened and how is it going to go, printed, dried and then rolled again. So, what we will not do? Obviously, there will be nothing called a fixation. You will do print and dry, but there is no fixation. Drying itself is okay. That means either ink is such which actually makes a small little film, or it just gets little absorbed, and so that it is. So, in-house manufacturing, cutting out for a commercial printing could also be thought of, those who want to do. But rotary screen printings are not so fast. Otherwise, textile people believe rotary screen is fast. All right. For paper industry, they say too slow. It should go much faster. And so, you may or may not like to use. So, therefore, in general, the people who print the textile actually do not print paper, although they can do that. So, that is one important thing, and the paper printing industry generally have their own different technologies. So, while screen printing can be used as it is and you can do the printing, of course, viscosities will have to be adjusted while you are printing, but then they will have their own ways to print. One of the interesting printing processes in the paper is called the flexographic printing. Now, flexography is something like a block printing. So, the way we have block printing, where the design is like a relief, it is coming out of the surface. All right. A block has the design outside the whole block. So, it is like a relief. So, similarly, or if you have seen, if any one of you have seen earlier printing operations of papers, they used to have a letter press. That means the letters are lying everywhere. You pick up A, B, C, make your spellings and keep adjusting the thing and then start printing. So, there it is also the letter is in relief, it is relief. So, like a block, you take the block, put it in on a pad, ink pad, and then ink or the color is picked up only on the relief portion and then you transfer. So, this is exactly similar. For example, you can have some type of a design which is raised, but instead of a wooden block, they can have a plate, a metal plate for that matter, which is flexible enough, and then you can put it on a machine which is, let us say, a print plate cylinder, as they are calling it, plate cylinder. So, everywhere you may have some plate which has a design, and the design is in a relief mode, right. So, and then you wrap it around, and it can be used, as they say, for paper printing or labels or plastics also. So, this technology is therefore available for doing this type of job. So, this is in some sense a continuous method of printing. So, this is how the paper can move, and here you compress, all right, you compress here, and this pressure and transfer will take place. So, you have a ink which is in some trough, then you have some transfer roller, then there is any locks roller they call it, which have got small grooves which picks up the ink, and then it gets transferred. So, only thing which is interesting here is the ink obviously touches only the design portion, it should not go beyond the design, that is the only thing is there. So, that control one has to make, and then you transfer and dry and work it out. So, it is an extension of a block kind of a printing, but in a continuous manner, all right. Wooden blocks are too rigid to be made flexible, so you have plates. Sometimes they were also called stereo rollers, they carry the design in relief, okay, flexographic print roller. So, main thing is there is a plate and the plate can be fixed. So, instead of everything being on a design which is permanently fixed on a roller, this technology says plate can be made somewhere else, you can come and fix it here. So, the design has to be made and transferred only onto the plate, and the plate can be put on the roller. So, they can be also more than one printing rollers. So, 6 or 8 like the way we already know could be there, and they can be arranged around a large drum or which is carrying the paper, and you have like in a roller printing machine also you have a large drum and you have one roller, then the other roller and the other roller all along. Similarly, here also the same arrangement can be done. So, one color versus the other color and the third color, and then you finally print. So, in a continuous manner. So, instead of textile, it is the paper which is going. So, this interesting remains that as the raised portions come into contact with the paper, there is no need for drying between the print stations. So, you have one print color, then you do not really have dry, because it is obviously the other design is not going to be coming onto the print if everything is nicely civilized. So, there is no need of a drying between the prints. Otherwise, if you believe that your next roller is going to actually roll over the other design in a manner that it actually touches the colored portion also, then either the ink formulation or the heating etc., will have to be done, so that as it moves to the next it gets dried. So, this has one advantage. So, you can think that this could be a batch process also. If you are just have a letterpress kind of thing, it goes one way, then the next page and the next page and the next page, or it could be continuous roll machine. So, this is one which, let us say, in very early days was a popular printing process of paper. So, what is interesting is that if suppose the paper gets wet during printing, the stability comes to play there. Suppose it slightly shrinks, slightly curved, it gets curved, and then there can be problems. So, then you believe that because this is a thing which does not require any of those over and over printing. So, dimensional change during drying, because whenever you absorb something and dry again, you can expect something. You can think of any paper, put little bit of moisture and then try to dry, you will see stability in that area is slightly different compared to the rest of the paper. It measures the flexibility, those kind of changes can be there. So, what it means is that instead of a fast drying things, you can use slow drying solvents also, which also means if the fast drying solvent means that its vapor will also come to the environment. It is obviously not water, right. So, the next technology which is used for paper printing is called also gravure printing. Now, this is exactly like a roller printing machine, because here the design is engraved. In a roller printing machine, the design is engraved onto the roller, right. So, in the previous case it was a relief, the design is outside the main surface. Here it is engraved, and this is what we have in the textile roller printing machines also. You have designs engraved, and excess ink is removed by a doctor blade, like you had a doctor blade. So, it is more or less similar machine. So, ink roller is brought in contact with the paper under pressure, ink is almost completely transferred to the paper, that is what the principle is. Here, because everything is smooth, the most of the roller surface is plane and design is inside. So, you can actually think of increasing the speed. If suppose you have rough surfaces which are edges pointing out and you want to do that fast, then you may have some impressions of the design which is not just the color, but the edges can also press the paper, and so you may get different impressions and made on. So, you say go slow, right. Here you say, because both surfaces, the transverse surface of the engraved roller as well as the cylinder on which the paper may be moving, or a blanket on which it may be there, they are all full. So, pressure is in some sense distributed all over, and so you can run it at a higher speed as well. So, it is similar to roller printing machine. The difference is here. So, it prints dots. When you talk about the design is engraved as a dot. For example, if you have this type of a design, so here you actually have dots. So, do indenting, or it could be done by any other method, but it is like dots are inside. So, you have all the area, design area is covered with dots, and so color will go inside the dots and then it will get transferred. So, the whole design is, when you say engrave, it is not that you have etched out everything from that area. So, only that there are fine dots or less fine dots, but there are dots. Okay. And this principle itself has led to great advancement in the printing technology, that you just have dots. So, if you take any printed paper and look in the microscope, you will see that there are dots, colored dots all over the place. So, they engrave the dots around the design, whichever the design is, so that the boundary is also clear and the color gets transferred. And so, as I said, the visible means that you can actually go and see under microscope, these dots will be visible. The drying between the prints, you may have to, all right, because the portion which comes over the in contact is also the portion which has no design on it. So, you print, the next roller will come. So, here may be fast drying inks you may have to do, and or keep the distance between the two stations larger, but or heat them up or do whatever, so that there is no smudging of one roller to the other roller. Right. So, this just shows the difference. In the textile, this is done. Textile printing roller, they do not have dots, they have lines, parallel lines being etched. So, you probably be aware that you will have a polymeric layer coating on the roll, and then there is a machine which maybe you know called pantograph. Have you heard of this machine? So, when you have a roller over which there is a polymer coating, so how do you etch the design? So, design is on paper, somebody has made the design, let us say, and this machine is that you, one end of the machine is moved over the design, the other arm gets moved automatically over the roller. So, there is a magnification or contraction. Maybe if a design is very large, it is easy to do certain things, then you keep doing it, and this can make smaller etches, or the reverse of it, that you have a small design with your hand and you are making your effort on the small design, and on the design, let us say, if you keep running the needle of the pantograph over the design and then you keep etching marking on the polymer film, and this becomes your design. And later, of course, you can do etching by acids or something, and finally the polymer layer is removed, and what you get is a etched design where the fine lines are there. Now somebody asks, why do you want a fine line? Why not just remove the material from there, just etch, because acid can eat it up, the whole thing, rather than only the portion where the polymer has been removed. Okay. Can you tell me why? It's a roller. This etching is being done on a chrome plated roller. So even if it's a thick paste, and if there is just a groove, big groove, roller has to move, one will find that just by gravity itself, the print, when it is vertical, the whole paste may like have a tendency, or ink may have a tendency to come down by gravity. And if you have these etchings, so ink is only in the etched portion, and so there is like a barrier or a dam at every point, so it does not come down. If the whole design is just plain and there is some depth, half mm or less than half mm, whatever, you will find the color cannot be held in the design, and therefore this is done. But when you transfer, because of capillary action, these lines are never seen. Okay. In the case of paper, instead of lines, you are putting the dots, and so the ink goes in the dots only, and then gets transferred as a dot. And if they are very close, you do not see the dots, but if you go very close by a microscope, then you can see the dots also. So this is how they do what we call as the gravura. So there is engravings. This is one of the latest ways of printing paper, which is called lithographic printing, also known as offset. So a large number of people who go for getting anything printed, they say, well, want an offset printing machine. High quality and high volume prints. If suppose somebody is doing printing of a book, so many pages have to be printed, so many copies of the same page have to be printed, like even newspapers today. So you will go for lithographic printing. So you make plates the way you make plates, and the plates are put on the roller, and then the print keeps on taking place. But it is really an advanced level of printing. So the principle is simple, but interesting principle. So although there is a design to be made, but the important thing is the ink is oil based, and rest of the roller is, let us say, treated with water. And because ink and water do not mix, so when a transfer roller comes in contact with a roller where the design is there, oil based ink goes to the portions where there is a hydrophobic film, and it does not go to the area where there is water. And so you do not need any engraving, you do not need any other thing, just that this ink, if it is oil based ink, will go to the hydrophobic portion of the design. So wherever there is design is hydrophobic film. The ink goes to the hydrophobic site, stays there. Rest of the roller is wet. The rest of the roller is wet. So even if all the ink, so the transfer roller, when it transfers the ink, fortunately ink goes only towards the oleophilic portion, which is the design. Then it is transferred on to another one where the ink gets transferred. So ink is only on the hydrophobic part, and so from the hydrophobic part goes to another transfer roller, and from the transfer roller it is then transferred to. So, 2-3 steps. One, obviously you are going to be making a plate which will be on the printing plate roller, but the plate is first made a design with polymer systems which are from the hydrophobic material, and oil based inks will go only to this thing, although the transfer roller has ink everywhere, but ink does not go to the water, it just does not get transferred. And then from the hydrophobic portion of design which has the ink, you transfer it to another roller or a blanket, and then this blanket or a blanket containing roller will transfer the design to the paper. Right. So, the principle is simple, oil and water do not mix. So, the more interesting part is they can produce photographic quality printing. Your letter printing could not do it, and very difficult from others to do it. 4 rollers, 5 rollers printing machines will not be able to do it, but they could do it photographic. So, what you are doing is that you use only 4 colors. You can use only 4 color, yellow, magenta, cyan and black, and that is for these days when a paper printing you say is a 4 color printing. 4 color means you are using 4 colors, but getting every shade, right. That is lithographic printing, and therefore, it is more popular today. So, here also you may still have dots, right. So, one of the roller is printing yellow dots, other roller is picking up magenta dots, and they are being placed over each other. So, you can just think, if you mix yellow with magenta, what color will obtain. Now, how much yellow and how much magenta would also depend on how many dots, what is the density of the dots of the magenta and yellow. So, main thing is you have to first be able to separate any kind of a color, a photograph or print design into 4 different varieties. That is the most important part. If you can do that, then it is adding again. First separate them so that you make 4 different rollers or 4 different plates, and then once you have done that, then you just print it in the same manner. If you do right, you actually reproduce exactly what you saw. So, this is one of the most popular printing technologies, which sometimes called lithographic printing and also sometimes 4 color printing, and also with just 4 colors you can make, but does not mean that you can not use only simple printing. You can just use 2 color which is not photograph. So, it is no problem, you can just make designs black and white. So, you just take one black plate and just keep doing it, or any other design. So, every design can be printed, but a photographic also can be printed, right. That is one interesting part of it. So, the plates have a roughened texture, were first coated with photosensitive, like a roller printing machine or a rotary printing machine or a screen printing machine. You also have photosensitive lacquer which is sensitive to light. So, you have your designs, then you expose them to the light, then remove those portions which you do not want. They are washable because they have not been exposed to light. So, they are water soluble, and what remains is a hydrophobic design at the end of the day. So, this is exactly the process which you use for generating any screen, right. So, you have design which is fixed by exposure, and after that you remove, and then what remains is this, and then the same principle, oil, water do not like each other. Okay. So, 4 steps. Obviously, before also you have to have a design first. The design is, let us say, on a transparent material. The film is coated all over, lacquer is coated all over the plate, dried, and then exposed to design. That means the light goes, wherever the light goes, it becomes hard. So, your design has to be negative. So, that so you have to negative positive combinations you have to make, which is what you are going to make, right. So, one is going to be wherever you had the design, it will not be there, then you will have the material. So, you have to make sure that whatever you want is actually hardened, all right. And then obviously, the design also must be having what we call as the dots. Okay. So, texture is rough texture in that sense. And then finally, a hydrophobic design which can be used for transfer. Amount of ink delivered to the paper by this plate is very small. There are no engravings, nothing is going inside, just a layer. So, you are looking at 1 to 2 micron thick layer, which is very thin, and therefore, transfer from one to another is not too much of a mass transfer, and so you just can be quick, but the concentration of the color could be very high, as high as 50%. So, this is how this technology is used. Now, what we have to do is how to use the same technology and use our dyes. Our dyes are going to be different than the paper dyes, paper inks. The paper is not to be washed, but the textile has to be, and therefore, you are talking about a different thing. So, when people started talking about transfer printing, the paper printing were using different kind of inks, which were good for them. And whatever they are using today also is not, everything is not being transfer printing, it's just for paper printing, and that remains as it is. But the moment you want this should get transferred, then the nature of the dye will have to be checked. So, for today, we think these are the 4 technologies that can be used for printing paper, having different principles. Some of them are similar to the textile printing, and lithograph is very different. So, there we stop today.